Alright, so today we're going to be talking about angle relationships inside triangles. First with our triangle sum. So our triangle sum theorem tells us all the angles of a triangle have to add to 180 degrees. And you've probably seen that before at some point in elementary or middle school math classes. Today we're going to formally prove why this is true, and then we're going to use it for different math problems. So the proof. So we are given triangle ABC, and we want to prove why angle 1, 2, and 3, the three angles of the triangle, have to add to 180 degrees. So we'll start with our two-column proof, where our first statements are given, statement triangle ABC. That's what's given to us. Now, we need to find some way to bring 180 degrees into this problem. So the only thing besides triangles we know that add to 180 degrees are lines. So I need to draw a line. Now, not just any line though. I need to draw a certain type of line. I need to draw a special line. I'm going to draw one that's parallel. Draw a line BD. So that it's parallel to side AC through point B. So we're going to draw BD parallel to AC. We can do this because of our parallel postulates. If you remember from a previous section, parallel postulate told us that through any point we can draw a line parallel to another line. And that's what we just did. We drew a line through B that's parallel to AC. That forms these angles 4 and 5. Well, 4, 2, and 5 are all supplementary angles. They're angles along a single line. So I can say they add to 180 degrees, because they are supplementary angles. Well, the reason why I want to draw a parallel line is I could have said if I drew any line through B, 4, 2, and 5 are supplementary angles, they're on a line, that's fine. The reason why I want parallel is because 4 and 1 represent alternate interior angles. And since we have parallel lines, they are equal. And same thing with 3 and 5. They are also equal because they are alternate interior angles. Well, if angles are equal, I can replace them with what they're equal to. So I can replace angle 4 in this expression for angle 1. I can replace angle 5 in this expression for angle 3. And now we have, based off substitution, exactly what I want to prove. All three angles of a triangle adding up to 180 degrees. So there's our formal proof for that. So let's use it now. So I want to solve for x for this diagram. We have 6x minus 12, 3x plus 4, 10x plus 18. And if it's a triangle, which it is, all three angles must add to 180. So we need to first combine like terms, so 6x plus 3x plus 10x is 19x. Negative 12 plus 4 is negative 8, plus 18 is a positive 10. Subtract 10 from both sides. 19x equals 170. Divide both sides by 19, and then you can leave it as a fraction, 170 over 19, or as the decimal, it's going to be 8.947. Both are acceptable. So yeah, that's what you gotta do when you're given a triangle. Add all three angles together, set it equal to 180 degrees. So do that for this one so you can solve for y. Alright, when you do that, work that out, you should get y to be, as the improper fraction, 169 over 18, or as the decimal, 9.38, where the 8 is repeating. That's all you have to do for your triangle sum theorem. Now the other thing we're going to talk about is exterior angle theorem. This tells us that our exterior angle, which in this case is angle 3, is equal to the sum of the two remote interiors, 1 and 2 in this case. By remote interiors, I mean we have three interior angles, angle 1, 2, and I call this angle 4, 4. 1 and 2 are remote because they're not on the same line as angle 3. They're not connected like angle 4 is. So that's why they're two remote. If I add these two together, they will equal angle 3. We're going to write the full proof for that as well. So we want to prove that angle 1 and 2 add to be angle 3. given triangle ABC. So that's our given statement. Now let's add an angle 4 right here into the diagram. We can always label into the diagram wherever we want. Well, 1, 2, and 4 are all angles of a triangle. Therefore, they all have to add to 180. That was our triangle sum. 3 and 4 also represent a linear pair. Therefore, they also must add to 180. And if both expressions add to 180, they must equal each other. So angle 1 plus angle 2 plus angle 4 equals angle 3 plus angle 4. That's our substitution property. And then we notice angle 4s are on both sides of the equation. They can subtract out, leaving just angle 1 plus angle 2 equals angle 3, our exterior angle. And there we go. Our two remote interiors, 1 and 2, have to equal angle 3 when they add together because of this proof right here. Which again makes logical sense. The whole thing adds to 180. This also adds to 180. They share this piece. Therefore, they must be equal. So let's use that. So we want to find angle 1 in this diagram, which is this right here. This is not 1 degree. Degrees will be measured, signified with this little 0 in the superscript position. So if I want to find angle 1, well, these are my two remote interiors. 67 plus angle 1 equals my exterior angle, 89. I subtract 67 from both sides. Angle 1 is equal to 22 degrees. Very straightforward, very easy. I have this expression. So again, I have my two remote interior angles, 7x minus 2, and my right angle, which is 90 degrees. So I'm going to say my two remote interiors, set 90 plus 7x minus 2, equals my exterior angle, 135. So 7x plus 88 equals 135. When I subtract 88 from both sides, 7x will equal 47. So when I divide both sides by 7, the fraction will be 47 over 7. Its decimal equivalent is 6.714. The key is just to again identify your two remote interiors and add that together to equal your exterior. So go ahead and solve for x4 this problem using that same concept. Alright, as your fraction, x will equal 3/2, whereas the decimal is 1.5. Okay, so that's how the angles of a triangle are related to each other. We're going to talk about next time special properties of triangles, isosceles and equilaterals, how they relate angles and sides together. So I'll see you next time.